All right, here we go with this statistics information. Remember, this video is probably going to be a little bit long, so you might want to do it in pieces. And I'm going to try to go a little bit fast. Here we go. So, with statistics, what you have to know is, statistics are about data or data. And so when you have data, you can make like a little chart about it, right? So like, let's say you're collecting information and, you've seen these before, like a little bar graph or a histogram, right? And so this is just saying how, you have like, oh, there's 25 people in this group, like right here, right? And so you've seen this before. And so when you have data that is, like all basically like the highest part is like right here, that's called skewed left, so it actually seems kind of like opposite, and it's called skewed right when it's like over here. Now this one's like all over the place, right? So you can't really say one thing about it, but there is a special one called when something is normally distributed. All right, so like a normal distribution, when your data basically kind of like is even on both sides, right? Like it's high in the middle right here, and then it has, tapers off and it tapers off. So this is called a normal distribution when it acts like a bell curve. And it's called a bell curve because like it literally, looks like a bell, right? Like the Liberty Bell or whatever. So that's what this whole little chapter is about. It's about when things are normally distributed. And so when something's normally distributed, you have three different things that can talk about the middle. You have the mean, the median, and the mode. So that's like your center right here. Okay, I think it's on the next page. And so with a normal distribution, the mean, the median, and the mode are all supposed to be the same number. So remember, the mean is when you add up all the numbers and you divide by how many there are. The median is like when you put the numbers in order and find the middle. And the mode is the number that occurs the most. And so when you have a normal distribution, it's supposed to be that those are the same numbers. And then half of your data is below the middle and half of it is above. So those are some kind of important things about this. Okay, so first we're going to talk about something. Let's see. So I was going to do this, but I think I'm going to skip over it. But when you have some data, so I have this data right here, all right, and if I found the mean, I was going to put it on the calculator, but I guess I will. 2633. I don't think I have my calculator on here. Never mind. All right, so I'm going to do it on my phone real quick, all right, and so you can just, I don't know, skip ahead for a second so that I don't have to bore you with like figuring this out. But anyway, if I put this in my calculator, I'm going to put it in my lists, and I'm going to just basically like put all these numbers in. Let me give you a second. So 26, 33, 65, 28, 34. 50. I'm going to do the rest of the stuff on Desmos. You don't really have to know how to do this. I just wanted to explain a concept. All right, there we go. Stat calc in there. All right, so if I were to calculate the mean of this data, all right, so the mean of this data right here is 38.25. So that would be like the center. Now, this is not normally distributed data, all right, but then there's something called the standard deviation. So the standard deviation of this data is 12.2, let's say. All right, that's what's about that. All right, so look. So this data, if you look at it, the smallest number up here is what, 26, I think, 25, nope, 26. All right, and the largest looks like to be about 65. Yeah. All right, so this data goes anywhere from 26 to 65. And the center of it is about at, 38. So this is not normally distributed data, but there's something called the standard deviation, and it has a formula for it. And so, but I just need you to know that the standard deviation is basically a number that tells you how much your data differs from the center. It's the average amount that a data value in your list will deviate or be different from the middle. So you see like this has a big standard deviation. So this data is like really spread out, okay? Whereas over here, I've already done it. In this data right here, you see how all the numbers are closer together. And so the mean is 13, and the standard deviation on this data when I calculated it was 2.12. And so that's a lot smaller. This data is like tighter together. So I just wanted you to understand what the standard deviation is really, because we'll be talking about that in a minute. So when your standard deviation is really small, that means your data, if you look at it, your data is really like close together. Whereas when your standard deviation is larger, your data is more spread out, okay? And the standard deviation is a calculation. It basically takes each data point and subtracts a data point from the mean, and that number, you take the average of all those numbers, of the average of all the deviations, all right? All right, so if you're going along here, so the bigger the standard deviation, the more spread out the data is. Each data set has its own mean and standard deviation values, all right? But with a normal distribution, all right, the number of standard deviations you are away from the middle always cover a specific amount or percentage of the bell curve, all right? And so with a standard deviation, what's going to happen is like these little areas right here, like here, here, and here, always are the same amount because your data is normally distributed. So you have to be told that in the beginning. All right, so what it's going to do is this inner part is always going to cover 68.3%. Then when you go out to 2 standard deviations from the middle, so 2 above or 2 below, so 2 below or 2 above, then you're going to have covered 95% of your data. And then when you're all the way to the 3, you'll have covered 98.73. And so those get broken up. I think I have the picture, yes, like right here. What you want to remember, or what you're going to use, is this 34.1, 13.6, and 2.1. So those are basically like the values of the 3 areas, or 3 regions right here on either side. And so with the standard deviation, that's what happens all the time. Okay. All right, so let me erase some of this stuff out of the way. Okay. All right, so let's just try it a little bit here. The number of cookies in a box of bite-sized cookies is normally distributed with a mean of 55. So that's going to go right here in a standard deviation of 2. So that means when I jump up to the next bar, it's 57 and then 59. And I should do, there's one more over here, that would be 61. So what's going to happen here is like there are 34% of the cookies are like in this area right here, because that's what that number is, like right there. Okay. All right, and then so on. And so let's go ahead and number the other way as well. 55 down 2, that would be 53, and then 51, and then 49. So my question says, shade the region under the curve that represents a probability. So what I forgot to mention also is that this normal distribution is meant to get you the probability that something's going to happen. The area under this curve is equal to 1. And so if you added up all this space, it's equal to like 100%, or a probability of 1. And so when you do probability, your answers are always a decimal between 0 and 1. Like, think about like when something has 100% chance of happening, that means the probability of it happening is 1. When something has like a 50% chance of happening, the probability is 0.5. 75% chance of happening, that'd be 0.75. And so the closer to the 1, the better. That's the higher probability. And then the closer to 0, like the less chance it's going to happen. All right. So I want 53 and 61. So 53 is right here and all the way up to 61. All right. So basically what's going to happen here is I'm going to add up these pieces. I got my 34.1. I got 13.6 and 2.1. So those are all those numbers I'm getting from there. And then this is another 34.1. So what you would do is you would add up all these things. All right. Now we're going to figure out a way to do this on Desmos as well, but I'm just showing you the concept here. All right, so you'd add up those percentages and that would be the probability. So let's see, 34.1, that's 68.2, 13.6 and 2.1. So let's see, that'd be a 9, 8, 13. So 6, 7, 8. 88.9%. So if somebody asks you a probability, though, you have to change it back to a decimal. So 88.9% would be 0.889. That would be the probability. So today, a shipment of 80 boxes of bite-sized cookies has arrived at your store. So it's approximately how many of these boxes are going to have between 53 and 61 cookies in them. So what we're saying is that every time you get a shipment, this percent of your shipment is going to be in this category. So what I have to do is do 0.889 times 80. Right? And so when you do that, let me see my little Desmos. So 0.889 times 80. Right? So about 71 of the boxes, right? So we'd say like 71 boxes. And you can round up or round down. It usually doesn't really matter. Like there are different thoughts on that, right? Because you can't have part of a box. Okay. All right. So just a couple of little questions here till we get into other calculations. In the diagram below, the shaded area represents approximately 95% of the scores on a standardized test. So what we're saying right here is that this is 95%. So remember, if you go back to your stuff here, 95%, so it's probably about 2 standard deviations on either side. Okay. Let's see, the scores are normally distributed. The central area is 95%, ranges from 78 to 92. So 78 to 92. So I got a couple questions about this. What is the mean score? So the mean has to be in the middle, right? So I have to find the middle of 78 and 92. So, I mean, you could count it out, or you could say to yourself, well, if you go 12 up from 78 and 12 down from 92, that's going to be 80. If you really wanted to, you could, take 78 plus 92 divided by 2, and you would find the middle that way also. But I think this one's kind of easy to kind of count. Then it says, what is the standard deviation of the test scores? Well, like I said, this right here, we're about at standard deviation is equal to 2 right here. So the distance between the center and 92 is about 2 standard deviations. So I can divide that area by 2 and then figure out how big the standard deviation was. So if I'm going from 80 to 92, that's a distance of 12. I divide that by 2. So that means my standard deviation is about 6, right? Because we knew that 95% means that we were about 2 standard deviations on either side. Excuse me. All right, so you'll be finding the area under the curve sometimes. And what we were doing here, all these problems that we were just doing, we were staying on these lines right here. But, not everything's going to be all perfect like that. So there's something called a z-score. A z-score is basically going to tell you how many standard deviations, we're near in the middle. Your z-score is 0 because you're literally on the center. And a z-score is going to tell you how many standard deviations you are from that middle, all right? So if your z-score is 1, then you're going to be 1 standard deviation above. You're going to be on this line. Your z-score is 2, you'll be here. 3 is there. Now your z-score can be negative, so you can be to the left or under the mean, okay? So, but it's not always going to be perfect like that. It's not always going to be on the bars. So we're going to have an example here where the mean is 14. All right, the standard deviation is 4. So I'm going to go ahead and mark that up. So 14, I got 18, 22, 26. And if I go down, it'd be 10, 6, and 2. All right, so look, when I see 18, 18 is literally that first standard deviation line. So my z-score is 1 right here. But when I see 8, 8 is right here. 8 is 1.5 standard deviations below the middle. So that would be a negative 1.5. If I am 2 standard deviations above the middle, so positive is to the right, so that would be, I'd be at 22. If I am at a data value of 2, so right here, I am 3 standard deviations below, so negative 3. So we're just getting a feel for what the z-scores are. So your z-score is usually a number between negative 3 and positive 3 because you're either 3 below or 3 above. Now you can go higher, but then that's just a really small chances then. All right, so your z-score is negative 1. So you are 1 standard deviation below the middle, so you are at 10. If your data value is at 14, well, 14 is literally right at the middle. So your z-score is nothing because you haven't moved from the middle. And if you're at 1.5 above, that means you're 1 bar and then halfway. So you're like right there. So right between 18 and 22 is 20. All right. So these were all very easy to calculate the z-score, but you're not always going to be able to do that because the data values aren't going to be always nice and pretty like that. So there is a formula for the z-score, and it goes like this. It is your z-score is equal to the data value minus the mean over the standard deviation. Now another way to write that, so this means the mean, this means the standard deviation number. All right. Another way to write that is these variables. So x minus mu. So that funny looking u is actually a lowercase m in Greek. And then standard deviation is like a little circle with a little line next to it. That's a lowercase s. All right. So it has the same thing. This is your data value or your data point. All right. So if you want the z-score of something that is, just like random, that you just can't figure it out, like where it falls, then you're going to want to use this formula. So we're going to do that here. All right, so a corn chip factory normally distributed 12.4 ounces and standard deviation 0.2. So I don't have to like mark this out right here. Oh, but it says to do that, sorry. So I got 12.4. So I'm going to go up 1, 2, 3. So adding 0.2, that'd be 12.6, 12.8, and 13. If I go down, so that would be 12.2, 12, and 11.8. Okay, so it says shade the region that represents the percentage of bags that contain less than 12.7 ounces. So 12.7 would be, let's see, sorry about that. 12.7 would be about like right here. And I want less than that, right? All right. So calculate the z-score for 12.7. Now look, I can tell you 12.7 is exactly between 12.6 and 12.8. So I know that I am like 1.5 z-score standard deviations above, but we're going to do it with the formula. So my z-score, I would put 12.7, the data value, minus the mean, which is 12.4, over the standard deviation, which is 0.2. So 12.7 minus 12.4 is 0.3 over 0.2. So if you divide that in your calculator, you get 1.5. So that's my z-score. Okay. What's the probability that a particular bag of chips contains between 12.1 and 12.95 ounces? So, think about it. 12.1 would be over here, and 12.95 would be like really high. So I always draw a picture so I know that I'm getting an answer that makes sense. So it's a really large percentage or a really large probability. So now we're going to go to Desmos and see how to calculate this. So 12.1, 12.95, and we want our mean is 12.4 and our standard deviation is 0.2. So 12.4 and 0.2. So you go to Desmos, you go to this function button, and all the way down, I think it's all the way down. Yeah, we want, oh no, there's our distributions. We want normal distribution, and you have to put in your mean and your standard deviation. So our mean is 12.4, and our standard deviation, so comma, and let me just 12.4 and 0.2. So comma 0.2. Okay, so what we're going to do is click this button that says find the cumulative probability right here. And so that way we're going to put in the number that we want to start at and the number that we want to end at. And I've forgotten what those are. So it's 12.1 and 12.95. So I'm putting in 12.1 and over here 12.95. And there we go. And I forgot how to make the picture like work here. I think if I zoom in here, it'll show like a little hump, like a little normal distribution, but I forget how to do that. Anyway, 0.93, there's our answer right there. So that gives you the probability. So 0.93. So this one, what's the probability that a particular bag of chips weighs more than 12.3 ounces? So more than 12.3 ounces, that means I want to erase this right here. And over on the other side, for my minimum, I want 12.3, right? So more than 12.3, I want that infinity to be there. So 12.3, so let's draw a little picture of what's going on here. So more than 12.3. So 12.3 was like over here to the left of the middle. And I want more than, so I want all that. So I expect more than 50%. So that's why this is giving me 12.3 to infinity, it's 0.691. So these are the things that you're going to have to do on the SOL test, all right? So in a shipment of 500 bags of chips, how many would you expect to contain more than 12.3 ounces? Well, look here, I got 69%, and I need to know what 69% of 500 is. So 0.691 times 500, okay? So 0.691 times 500. All right, so 345 bags. Okay, all right, let's see. All right, so I think what I'll do now is I'll just go and go to the questions that we just covered before we go into this last part right here. Okay, so let's do these SOL questions here. All right, so on these SOL questions here, let's take a look. Let me see if I turn this because I think these are lines. Yeah. All right, so the test scores of all students on the 10th grade English test. So this picture right here is going to be for these 3 questions on this page, and also I think this one right here. Yeah, it's going to be for quite a few questions here. All right, so we have, look, they've told me, they showed me a histogram, and they've said these important words, normally distributed. So that clues me in, oh, I'm going to be using my z-score and all that kind of stuff. The mean is 550 and the standard deviation is 82. Okay, all right, so down here, the students' test scores of 488 and 612 have the same z-score. So to have the same z-score, you would have to be the same amount above and below the middle, all right? And so z-scores can be positive and negative. So 488, the middle is 550, so like right about here. So 488 is going to be on this side. 612 is going to be on that side, so that would be a false. The only way you can have the same z-score is if you're testing the same number, all right? The student's test scores appear symmetric about the mean. So yeah, and that's what normal distribution is. The interval from 632 to 714 contains 47.5% of the student's test scores, all right? Well, so let's go see. Mean 550 and standard deviation 82. So 550, so let's start over. So look, functions, you go down to distributions. So 550 is the, what's it called, the mean, and 82, I'm gonna check that again. 550 and 82, all right, so they want me to check 632 to 714. All right. So they want me to check from 632 to 714. And look, 632 to 714 is 13.6%. So 0.136, I guess. Let's check those numbers again. 550 and 82, sorry. 550 and 82, 632 and 714. 632 and 714, yep. And oops, that's not what that number was, right? It was 13%. So I will say no. So false. All right. Here, the principal of a high school in the state wants to compare the data from her school students with the data in the histogram on the same test. So look, this was the scores of the students. So it was the whole state, it looks like, right? And then we have a specific school trying to collect or trying to compare, okay? All right. So should the principal randomly poll the 10th graders in her school asking what was the score they received? I don't think so. Ask the school administration for the data that contains all of the test scores for the 10th grade English assessment for her school. That would be a yes. Have every third 10th grader. So these are just like different types of sampling you can do, but you know, the best thing is going to be to like, hey, let's compare her school, like everything in her school to everything in the state, right? Give a questionnaire. No. So all the rest of those are kind of silly. All right. So Michaela and Josh down here. Michaela and Josh each took the state 10th grade English assessment. And we have here that we have a z-score for Michaela's test score is negative 0.1. So look, that means if the mean was 550, Michaela has a negative z-score, so her score was like over here somewhere, right? And then Josiah, has a test score of 1.4 z-score, right? So he's like up here, and he's also a little bit higher than the middle than she was lower than the middle, all right? Complete the sentence to best compare Michaela and Josiah's test score. All right, Michaela's test score is approximately 541. Which is about something points. Well, you know that her score is going to be less than Josiah's score because Josiah was above, but we need to go ahead and like find her score. So Michaela, remember z-score is the x minus the mean over the standard deviation. So her z-score is negative 0.1. The mean and the standard deviation are known to us. That's 550. And 82, and I just don't know what her score was. All right, so I'm gonna have to multiply 82 by negative 0.1, and then I'm gonna add 550. So negative 0.1 times 82. So negative 0.1 times 82. All right, and then I'm going to add, oops, let me just go back here. I'm going to add 550. 82, sorry, add 550. All right, so 541.8. Right, so I will say her score 541.8. And okay, well, they said that. Oh my God. Oh, now they already told me that. I should not have done that, which is about how many points less than Josiah. So I need to figure out Josiah's score. So his was 1.4. I got x minus 550 over 82. Like they already told me that was 541. All right, so I'm going to do 82 times 1.4. I'm going to multiply that over there, then add 550. So 1.4 times 82 plus 550. So I think I'm going to change this over here. So 1.4 times 82 plus 550, so 644.8. So his score was 644.8. So if I subtract those two, 644.8 minus 541. So let's see, 644 minus 541, that's 103. All right. So I'm just going to go with like this one. It's the closest, right? Let's see, which is about 107 points less than Josiah. Okay, yep. All right, I don't know why it didn't come out too perfect right there. Let's see, 1.4 times 82 plus 550. Let me just check. 1.4 times 82 plus 550. Oh, 664. I bet you were yelling at me the whole time, weren't you? 664. Minus 541. Okay, well that makes a difference. 123. Sorry about that. So there we have it. Oops. Here we go, 123. All right, so let's do a couple more of these, and I'm going to stop this video, and I'll do the other part in a separate video. All right, so the test scores of all the state scores, so there they are again, same information as before. The data set containing the test scores on this test for Mr. Carter's English class have a median test score lower than the median for all the students. So it's going to be lower than 550. All right, which graph best represents the data for the English classes? So look, we still want it to be like kind of normally distributed, like, still like, kind of normally distributed, but we want the middle to be what was it? Middle lower than 550. So the middle of this right here, this would be higher than 550. I think this is the one right here. This is lower than 550. This middle would be higher over here. So I'm going to go with letter D. Okay. All right. So this last question right here is going to be, and then I'm going to stop and make a second video instead. All right, so here, a normally distributed test set of 968 values. They have a mean of 108 and a standard deviation of 11. So I like to kind of draw it out. So mean of 108, standard deviation of 11. So 11, so whatever, that I'm not going to make other things. But it says I want to know how many, or what's the closest number of values. So like how many of these 968 are above 130. So 130 is right here. And I want to know how many. So whatever I get here, whatever probability that I get, I'm going to have to multiply that by 968 to figure out how many of them are up there. All right, so we need 108 and 11 for now. So remember, I go to functions, go down to distributions, and I need there was that picture right there. Did you see it? So there is a way to get that little hump to show there. 108 and 11. All right, I want to find my probability. So 108 and 11. I want to know from 130 and above. So I'm going to go down here, 130. All right, so 0.0227, or how about 0.023? So my next line, 0.023. I think I remember that it was 968. I'll go check real quick. Yeah, all right. So that's about 22. All right, so there we have it. All right, that's it for this part, and I'll go and do the rest of this, which is counting and permutations and combinations. All right.